Okay, so slide number 7. Lots of people just drew a random line, and you were right, it did move towards the normal, so you had the right idea, but it says in the question, accurately draw the ray. You need to take a measurement and carry out an appropriate calculation. You're not reading the question carefully enough. So I took an appropriate measurement, which was the angle of incidence, because it started in air and it was going into glass, so I drew the normal line at the point where it reached the boundary, and I measured that to be 35 degrees, okay, and I know that that was in air. I know n1 sine theta 1 must be equal to n2 sine theta 2. Now it tells you in the question that the refractive index of glass is 1.5, so this is n2, this is n1, so 1 for n1 sine 35 equals 1.5 sine theta 2. I know that I can rearrange that, so I'm basically doing sine 35 divided by 1.5 gives me sine theta 2, and that works out on the calculator to be 0.382 and some other numbers that I haven't bothered writing down, but I left it on my calculator. I then took inverse sine and found that theta 2 was 22.48. I can't measure that on the protractor, but I can go to about 22.5. So that tells me my angle of refraction, and I physically measured that with a protractor so that I made sure that I had an accurate ray at 22.5, and then I drew that line there, okay? But lots of people didn't bother doing a calculation, so you're not reading your questions carefully enough. So then slide 8, you've got another one that's before the focal point at this time, so I'm going to draw a ray that comes out through the top, and remember that that one goes through the focal point, so that goes down that way, and my next one is going to be through the centre. Make sure I've got that is in the right place. That's not too bad. Okay, so hopefully what you can see is that these two rays here are actually diverging, and so they're actually more likely to meet up here somewhere. Now, annoyingly, my worksheet means that it's going to carry on up into the previous question, but never mind, you're going to get the idea. So what I'm going to do is I'm going to extend this one. Sorry, this should actually already be dotted, shouldn't it, because it's a virtual ray, because it's actually starting from here and going into there. So this one is going to track back. Hopefully some of you should have spotted that my pencil's a bit blunt as well, and that you shouldn't be very happy with that. And then this one here will also extend back virtually. Okay, so what you should see, hopefully, now in the region where I know it's about to cross, what I'm going to do is just make it a bit more solid so I can see the point that it crosses a bit better. That's okay to do. Okay, and so there is where my image will be. So now, hopefully what you can see is my image is behind the lens. This is how a magnifying glass works. So if you imagine your eye would be over here, and then you've got the magnifying glass and the object is underneath the magnifying glass, you actually see the object inside of it that's bigger. So in this case I've got a virtual image on the same side as the lens. It is upright because it is in the same orientation. The top and the top are in the same orientation, and obviously it's also magnified, it's much bigger. Okay, so that's slide number 8. Let me move the camera down a little bit. Slide number 9. In this one, it tells you the size of the focal length, so you have to mark that on your principal axis. Sorry, I've got too much stuff on my desk. I'd be telling you off if it was your desk, but never mind. Right, back to a pencil. So I go from the centre of my lens and I mark the focal point there, and I do it on the other side too. Obviously 2 to 4 is 2. So that tells me where F is. Okay, and that allows me to complete the ray diagram. So I can have one that goes through the focal point. When it reaches the centre of the lens, it's going to come out parallel. So I'm just going to measure this distance here, and I can see that that's at 1.2. So I know at any point further along it's also going to be at 1.2, and that allows me to make sure that I draw a nice parallel line. I don't think I've measured that right, have I? That looks terrible, sorry. Goodness me. Right, 1.2 is actually here. That is better. Don't make the mistake I did. So that one's going to come out this way. Okay. And one that goes through the centre from the same point is here. And it's going to carry on. And so my image will be formed at this point. So I come across. Sorry, I'm very wobbly today. That's not great, is it? Let me spin that so it's a bit more straight for you. Okay. And so that's where my image is going to be. Now, hopefully it doesn't take a genius to work out that that object is much bigger, so that's 2. That's clearly less than 2. So it has been diminished. You can hopefully see that the top here is no longer pointing the same way, so it's been inverted. It's on the other side of the lens. And what else have I not said? So I've said size, attitude is upright, location, and T type. Yes, of course, it is a real image because real light rays are crossing here to form that image. Okay.